Hello, everyone. So, pleasure to be here. My name is Nestor, and I work for a company called Zephyr Cloud. We are a startup from the United States, and I am also one of the core team of Module Federation and maintain this library for famously making micro frontends and other federated applications. And I also work closely related with people working in the bundling ecosystem, so Vite, RSPack, and all that jazz. And today I want to take you guys on a journey. I want to take you guys into a little bit of an experience that I have the feeling that most of us have suffered to some extent. And I also want to tell you a couple of cool things that I built recently, and I want to share with the community. So, right off the bat, as a company grows, and those of you that work in enterprises might know this, you begin splitting the application in pieces. And by pieces, I mean that you begin splitting your team into different teams that work in specialized pieces of your application. Now, there is one dichotomy that happens when this happens. That is that one team that maintains one critical path, such as, for example, a checkout flow, does not work the same way as a team that maintains a highly trafficked component, such as, for example, the header. And of course, when you look at this point of view from the upper side of the application as a whole, you begin to notice and kind of judge, because that's what we all do at the end of the day, that well, one team is slower than the other for some reason. One might not develop at the same speed as the other, and therefore the product output of this team is not the same as the other one. But in my opinion, this is just a symptom of growth of an application. Now, it is important to say that, in my opinion, not every team should grow at the same speed. And this is something that is often overseen when we talk about front-end development, mostly because of the architecture and the tools that we've been using for the last years did not allow for you to split the work between each other. And one of these examples is as simple as that at the end of the day, everybody is building onto the same pipeline, everybody is building into the same application, and pretty much everybody ends up deploying the same way, obviously blocking each other. But again, the checkout team, capable of updating the cart of a shopping website, is not allowed really to deploy anything that they want and experiment as much as they please. So there's different velocities within different teams, and this is something that should be allowed. Now, the front end, as I said, often ships into a single thing. So you usually have one pipeline, maybe a couple more, but often just one at the end of the day, that bundles everything together, bundles every component, every library, every design system, every component library that you might have, and out comes the shell or the application that you are going to deploy. Now, this often is seen as something that desirable, that is nice, but when you talk about things from the other perspective of an application, such as the backend, right? Some years ago, maybe I believe around 2010, this thing popularized itself, which was called microservices, right? Oh, everything is going to be decoupled, everything is going to be able to be deployed independently, everyone is going to be able to deploy their own little applications and just scale on its own without any problems, right? Of course, that didn't happen. Eventually, we got some solutions around this problem. One of the very first ones was Docker with containers. That lasted very little. Later down the line, a couple of years later, some orchestrations mechanisms were born, such as Kubernetes, and that was going to solve all problems, which is obviously didn't either. But the ecosystem growth towards a path of independence between the different teams. And in my opinion, the front end eventually needed this change as well. And we are beginning to see this era today, especially more now with the new agentic workflows that we are working on. So this is the entire idea of one of the libraries that I developed. And it is that every team should be allowed to have different clocks, and every team should be allowed to be shipping at different velocities. But at the end of the day, what matters here is not about how you deploy your app. It's about how people consume it. Because at the end of the day, you might consider one API to be independent of each other, but the UIs and the UX of an application is composable. Like you need to consume the whole thing, regardless of the platform on how are you consuming it. So we have a hard dependency on something that we usually characterize as runtime composition, which simplest understanding as I have multiple things, I need to compose them at runtime, and I need to be able to change them at any given time without interfering with any other. So federation, module federation, changes this whole idea. So this is a very super basic example of one part of federation that I think is the best one to understand how this works. So on the side, we have like the typical import of a component of your component. On the other side, we have one snippet that is part of the federation runtime, one of our libraries, that allows you to do dynamic loading of an application. We can get deeper into this later. But basically, it's just like a general idea of how this works. Every component, every piece that you import on your application now becomes dynamic. It allows you to do it at runtime while the application is running, which means that if checkout widget points to something else, when it is evaluated or consumed, it will be something different. Basically, allows for this. This is the whole premise. Independent builds and that share code at runtime. Oops. So this is a little bit of a dissection of how this works without pretty much knowing nothing about federation. So above you have the load remote example. This is like the typical hook that we use on runtime. And you have two pieces. So you have the checkout, which is what we classify as a remote. When we talk about module federation terms, we distinguish between two things. We distinguish about hosts or consumers, and we distinguish about remotes or producers. Of course, this has a little bit of a dichotomy on it because one consumer could potentially be a producer as well, and so on and so on. But again, just stick with me on this one. The idea is that one remote, so one application, exposes X number of things. It's allowed to expose as many things as it wants. And the important bit, which is this shared thing at the bottom, is the shared dependencies, or what I like to call the contract that we are all in the entire graph is going to abide for. So what this means is that, okay, between us, we are going to share Vue, the Vue library, and we are going to make sure that it's being shared as a singleton, so we don't duplicate dependencies between us. And also, another side effect of this is that we are going to try to use the same version without having conflicting dependencies. Now, again, super simple, just to understand. By the way, works with it. This is another, this slide shouldn't be here, by the way, but anyway. This is the module federation package for Vite. We made it around 2 years ago. It is made by Giorgio, one of my best friends, and he pretty much maintains on his own. And it's also endorsed by the Vite team since recently. Evan, I don't know if you are here, but thank you. I love you. And essentially, it allows you to use module federation on anything that is Vite-based. But again, at some point, this was not enough. So I'm a React guy. I'm not a Vue developer, but I do enjoy the Vue ecosystem a lot. I think precisely because I'm a React developer, and every time that I use something with Vue, I keep asking myself why I develop with React primarily. But again, this happened to me recently with Nuxt. So I was developing one application and I wanted to hook federation into it for the sake of, playing around. And I realized that Nuxt has some complexities on it, more specifically talking about the SSR conversation. So module federation supports SSR already. Now, the only two places that I am aware of that is being used, first of all, is Modern.js, which is a React framework made by the ByteDance team and has federation baked on it and all of that. And the other place is on something that we call Module Federation Node, which is not technically for frontends. It's more for node applications that want to share code within themselves at runtime. So it's not exactly that. So when I thought about this, I was actually in a different conference. I was in Spain talking at MadVue, another Vue conference, and Daniel was there. Daniel is one of the core maintainers of Nuxt and is also a very good friend. And I pretty much told him, I would like to have this in Nuxt. I think will be pretty cool. And funny enough, apparently, there are many enterprises that use Nuxt that are also very interested about in module federation. So we paired together, I think this was about 2 months ago, something like that, in a stream. So we did a stream together in Twitch, and we began inside the official repo of Nuxt a module for basically module federation Nuxt, official, maintained by the Nuxt team. So that ended up being a separate repo. Over there, if you search for it on GitHub, you will probably find the work that we did on that stream. And after that, I basically took it up on myself, continued working on the Nuxt plugin. And today, basically what I just said, Nuxt had a couple of differences between what we needed out of the module federation Vite plugin and things that are very specific to Nuxt, enough to justify making something specific for itself. And essentially, this package was born. So right now, if you search on npm, you will find that this package is empty. I apologize. I was supposed to publish it yesterday, but internet is being a problem for me here. And also, I am waiting for the Nuxt team to release the new minor version that will migrate it to use Vite 8, which gives me the environment API, which gives me a lot more capabilities to be able to use this. So this package exists, it works with patches. So it will be released hopefully by next week, and you guys will be able to try it out and things. But the important bit about the official plugin is it will have SSR. It will be the second framework in existence to support module federation natively. And it will be basically completely integrated with the Nuxt ecosystem and the Nuxt niceties, such as automatic imports, such as type safety, all of that. So this is how it looks like. I kind of developed this together with Daniel. Basically, when you import inside your Nuxt config the module, it will give you this little array of configuration, and you will be able to expose everything here, configure it, all of that jazz. And when you go to the host, so the second application that is going to consume the previous one, this is how it looks like. It will tell you, okay, what is the name of this application? In this case, it's shell. I am consuming one remote that is called the checkout. It has type module. Ignore that, I need to fix that. It has the name checkout, and it is at this given URL. So this URL that you're seeing is where we ideally deploy the federated remotes. Here you can see that we expose one specific component. And here we're pointing to a mfmanifest.json that is a manifest file that holds all the references that we need to do, that holds all the chunks that Vite or roll down more specifically when it compiles the application is going to expose. And later on, you will be able to consume it. So as I said earlier, this is how we use federation. It's always consistent of 2 or more imports. The first one is the application, so it's this URL that we are talking about. The second one is the specific exposes, so it's the public key of the module that we are exposing for another application to consume. So this is how the workflow works. This is not actual code, but it is kind of like an idea for you guys to understand code-wise. So the whole idea is that you have an alias that's checkout. You get the MF manifest. The MF manifest is going to have information within it. It is going to await to resolve the entry of that manifest. It is going to find this specific file. This file is almost always the same. I am aware of some companies that like to rewrite it, but this is a very nice trick. If you ever want to know if an application is using module federation, open the network tab, search for that file. If that file is there, it is most likely that it's using federation. And later on, you get the container, you await it, and you will get the init and the get, which is, again, nothing you need to use. It's just there for us to use. And you can just use your application as normal, use a regular import. Now, the linking of the module, essentially, once the previous step is done, you get the container, you init it, you get the factory, you need to await it, again, it's a promise. And once you get the factory, you have the module to your use and everything else. Now, this is the important part that I wanted to get to. This is very cool on paper. Maybe some of you guys that work in enterprises and understand what I mean are very excited about this. It's interesting. It might allow your team to move faster, but this software architecture, and this is important to note, this has trade-offs, and it has a very big one, which is this one. you are changing the way your application, your team or your organization ships code, because you're changing a dependency that can rebuild the host for something that now contains a network and a version boundary. The network boundary is important because, as you saw earlier, we had a URL, right, for one given application, which for one application makes sense, right? I guess most of us here have different environments for our application. We have a development, we have a staging, and we have a production, right? Most frequently. So if we begin splitting our one application into multiple ones, it means that, of course, we are going to have development, staging, and production for those other applications. But now it begs the question, now when it comes to composing, right? I am going to compose development together with development, staging together with staging, production together with production, or not. And that is the problem. If you want to compose in a different way, you can, but it means that you're going to have extra infrastructure overhead. And not only that, you now have a contract to suffice, because if for any reason a team updates something within the pipeline of these applications that breaks the previous contract that I showed, now everybody is going to be broken, or maybe not, depending on the guardrails that you put in place. But again, this is all about changing and deciding whether the complexity is worth it, which in my opinion it is, but it depends on the situation, right? Now, all we've talked about here is frontends, and this is pretty much the whole idea that most of the use cases for federation are, at least on the West. Most of the people that use federation at scale use it on SPAs, and pretty much that only abides by the browser. Now, Vue runs on the browser. We pretty much everybody knows that, and this is kind of like how it works. So you get something, the Vue tree renders, the HTML get it, and the browser later on hydrates. But when we talk about federation, right, we need to produce extra bundles for this. So we had the remote entry that you saw earlier, and we also have a couple more that are kind of like hidden and hashed. But now that we're talking about a plugin that does both browser rendering and SSR, it means that the bundles that we produce need to be different. And not only different, it needs to have some logic for the application to know which one to use, which again is held inside the manifest, but that's besides the point. Now, hydration within the browser boundary is a promise. Like, you're always going to get the same output as long as you're using the same bundles, and you're always going to get the same identity. So you use the version 42 of an application, it's going to always be the version 42. Like, if you change to 43, it's going to be 43, and so on. Because if you don't, you're going to get a proper error. You're going to get like a hydration mismatch, or you're going to get something that you understand that, oh, well, I'm loading something wrong, or the build went wrong, or the development server is broken, right? Now, when we talk about federation, though, this doesn't happen. And it's one of the big problems that we have within the federation ecosystem, because now we have two types of remote entries, each one with a different format. Oftentimes, unfortunately, one of them has to be on CommonJS and the other one has to be on ESM, because there is no way around it. Sometimes both have to be CommonJS, because again, there's no way around it at the moment. But the most important thing is that if you happen to get a loading error, so imagine, for instance, something goes completely wrong and your browser is attempting to load a node server, you are going to get a type error, and that type error is going to be out of compile code, and that is not going to have any source map on it, and you are not going to have any idea what is happening. And most likely, because this is what most likely happens, your page is going to load, but it's going to load a white screen, which is commonly known as the white screen of death in the module federation ecosystem, because there is no way to debug that unless you understand some of the trade-offs, unless you understand some of the problems. There are some specific problems that sometimes happen. I know most of the React ones. I haven't delved deeper into the Vue ones, if I'm honest with you. But for example, there are some specific React errors that happen when federation loads incorrectly that you kind of can guess that why is that happening. But again, it's horrible. So you need a way to manage this. Usually the manifest advertises both. So this is what I was talking about earlier. We try to make our best effort to make this happen properly, and most of the time it does. Myself, with my limited experience on the SSR side, I haven't encountered any problem of this loading wrongly, but I know out of enterprises that happens, and I know people that have given up on the entire SSR conversation because it is way too complex to manage. But on Nuxt, the server sharing kind of like pins. So what I want to mean by this is that there is a shared scope that happens within the builds. So you can, because of the environment API of it, you can kind of like resolve both things at the same time. And on the node side, you can just pin the version that you are going to use, and everything should be good as long as the state stays the same, which again it should. So again, you just build twice. Each one of the builds of Nuxt is going to produce the right bundles, and at the end of the entire compilation process, we are just going to produce the same manifest for both, and everything should be good. And again, using this is as simple as that. You get pretty much, thanks to Daniel, by the way, you get pretty much all the niceties of Nuxt. We don't have this on React land, by the way, so another point for view on this. You get automatic imports of all the remotes that you're using. You get type safety over the wire as long as you have network enabled, and you also get server rendering as long as you set that in the configuration. You don't have to use client only for this. And pretty much this is the entire flow of how to use it within Nuxt. Nothing fancy to see here. Now, what I was talking about earlier. You have this working, it works on your local, whatever. Now you need to get this into production. So how do you know what is happening? So this is the big challenge, and this is one of the reasons why I work where I work. Because linking code is not delivering this code to the users, and it is all about operations and composability. So that's why we build this. So this is us. This is Zephyr Cloud. Zephyr Cloud was built, almost 3 years ago now. It was born out of something that was called Medusa. And Medusa was a product that aimed to give teams visibility into the different federated applications. But essentially, we realized that people didn't really care about that much. The really pain was into the deployment. So eventually, we rebranded and we became Zephyr Cloud. So Zephyr Cloud is a deployment platform, but we are slightly different as other deployment platforms in a sense that we are not a cloud. So we are not like Vercel or like Cloudflare or any other company, because we have a bring your own cloud model, meaning that in order to use Zephyr, you bring your cloud account of your choice. We have a bunch of them, and then it is used basically to. Why is my slides wrong? Yeah, basically, sorry. You bring your own accounts, and we deploy using this. So this is the unusual thing. Those are plugins for those of you that have used multiple bundles, but essentially we have one plugin for each pretty much bundle and meta framework there is, as well as some specific ones for no things or things that you don't want to bundle whatsoever, like Remix, for example. And the way to adopt us is as simple as installing a plugin, adding it to the plugins folder, and every time that you build your application, so every time that you pm build on your local, what we're going to do is that we are going to hook into the life cycle process of Bit or RSpec or whatever. We are going to watch the entire compilation process. If you're using Federation, and we will get into that in a moment, we will do a couple of thingies in there. But at the end, in the bundling ecosystem, there is like a seal process, right? So when the bundling seals the bundle, we are going to grab that and we are going to upload that into whatever cloud of your choice you're using. And what we are going to give you back is that we're going to give you back a URL that is immutable, cannot change. And the contents of that URL, which is that bundle, cannot change either. So that looks like this. This is a picture from our dashboard. More specifically, well, funny enough, the dashboard is this. So a little bit of an Ouroboros situation. But essentially, this is how it looks like. You can have different versions, you can have different tags, all of that SDLC process and whatnot. And this is the list of versions. So the important thing to note here is that you can see that pretty much everybody deploys, and we can see the versions from everybody. There is a little bit cryptic in a sense. I don't know if you can see that properly. I'm going to zoom out. But essentially, you can see all those numbers. That is 28,000 in this case. So every person within the organization can get their own number and their own versions. So for example, this means that I think this is Sergey. Yeah, so this is my colleague Sergey. So Sergey has built 28,000 times this application. So it has 28,000 versions deployed totally. And if we look closely to Leo here, he has 2,600, sorry. And every one of these is one URL. So this is how it looks. You pm build, you get a weird URL like this. If you bring your own account, of course, it means that you also bring your own domain and you bring your own DNS and all of that. So this will change. And then this URL, which again is immutable, it will get promoted to the different environments that you guys have. So if you have staging, production, or if you are doing like us, like we do preview environments on merge request and pull request, you can get one as well, and the URL will never change. Now, Nuxt can also publish to Zephyr. So this is the meta framework that I was talking about. We have to make some specific plugins depending on the different meta framework because of the niceties that they expose that bundlers alone cannot do. So in the case of Nuxt, the SSR conversation, so we can deploy SSR applications the same way. And the important bit about that, which is why I bring up the bring your own cloud conversation, was that we don't really own this, in a sense that the reason why we didn't build a cloud was because most companies and most enterprises do not want to vendor locking themselves out of one of these big providers. And oftentimes, if you are a big enterprise, you don't even have the choice. You have all your infrastructure on Amazon, maybe AWS, maybe Azure, Microsoft, or whatever. And you need something that instead of make you migrate over to something else, you need something to just integrate with whatever you have in place. So what we did is, okay, let's split this thing into two things then. Let's split the dashboard and management and orchestration layer into one thing that we are responsible for, that we need to maintain and all of that. But the other part, which is the operational part, like deploying, uploading, downloading, serving your users, that is going to be on your cloud account. I am not going to have any access whatsoever. So it's, GDPR compliant and all of those buzzwords for compliance. And at the same time, if you need to see what it does, you can just inspect the piece of infrastructure and look at it. Like there's no problem about that. We support several platforms. So this is currently what we support. Pretty much the Kubernetes one is kind of like whenever a container can run, it runs. And everything else on this list is pretty much related to, the internal services, the internal connections. If you use Cloudflare, for example, you can hook up things like D1, like R2 directly. If you use AWS, you can hook up Secrets Manager and specific integrations for each one. But essentially, you can use any of them, and that's it. Now, the important bit about the versioning is the paradigm change. Because every build is a URL and every build is a version number, it means that the SDLC of a traditional deployment changes. So it's not about running a pipeline anymore. It's about changing which version is this URL pointing to. So let me give you an example. If I build the application one time and I deploy the entire assets, and my colleague builds the same application from the same commit without any changes, uploading those assets doesn't make any sense because it is the same ones. It makes sense to keep a record of that and when was that deployed, but that's pretty much it. So what we do is that we do incremental deployments. And when you have to promote, so when you have to say, okay, this version is ready to go to production, you just change the DNS and that's it. It is sub-second. In sub-second deployment, you have everything in production without having to do any pipeline, without having to do any problems. Now, the cool thing is, what is the opposite happens? So instead of me having to deploy faster, I broke production. So I have to go back. Same deal. If I have to go back and roll back, the change is just a DNS change for the previous version that was deployed previously. And it happens sub-second, happens immediately, and within the developer tools and the dashboards, you get all the information you have for later on doing a post-mortem or whatnot. Now, I would like to give you a real use case of all that jazz that I've been giving you for the last 20 minutes. So you know as Zephyr Cloud, the cloud platform and whatnot, but lately, because it is what everybody has to do, we now have an AI platform. And this AI platform is called the AI platform because we are super original. And this entire platform is a desktop application that is meant to orchestrate organizations and is meant to be multi-human and multi-agent. So the whole premise of this is that we want to get the whole organization, so not only the development team, we want to get finance, we want to get design, we want to get product into the same place, collaborating with the rest of the company and collaborating using AI together, powered by federation. So one of the big problems that we have in the West, at least, is that many big organizations end up making their own tools for the needs that they need. Meaning that I've met uncountable companies that just happen to have like an internal CRM for their customer needs, and they just maintain it themselves, and pretty much only the accounting team uses it. So that escalate that into 10, 20, 50 apps, and it becomes a mess. What we like is the whole concept of mini apps. So having one shell that is capable of embedding everything within itself. And then with that, you have the entire organization using the same platform, yet giving them the possibility of creating and embedding their own mini apps. So this is how it looks like. This is the SDK. It is scheduled to be released, I think, Monday. And you just define one app in your application. So this will be whatever you want to do. It can be Node, can be Vite, can be whatever you want. Ideally, it would be a front end because you want to have something to see. But one simple SDK, expose it. So in this case, it's using RSbuild because that's what we did our demos on. But you will build it. You will expose one specific manifest that will be here. It deploys with Zephyr, so every single time that you build it, it is going to give you back one URL, and it's going to have this little manifest that is going to be used to consume. And within the actual application, I will show you in a moment, you just output this URL, and then another application little application is going to pop up in the list, and that is going to be yours, is going to be private, and is going to be scoped to your entire organization. So before we go to takeaways, this is how it looks like. So this is our tab. So this is our organization. Let's see if it loads because I don't trust my internet here. Apologies. And you can see people working here. So all of these people are my colleagues. They are sharing GitHub PRs around and all of that. And you can see that if we go to the workflows, so this is, I don't have any workflows at the moment. So this is our workflows. Workflows are procedural scripts that you can make your agents use. So I could make a manual trigger, for example. Okay, this is going to do an code execution of some sort. And then after it's done, I'm going to put that into my, where's my CVEC? Here, into my CVEC collection, which is like a vector database that we have within the organization. You have what we call specialists. So this is the specialist marketplace. These are essentially, you can treat them as agents, right? That we have people build. So for example, we have the PlanScale folks. If you don't know, PlanScale is a database company. They provide MySQL and Postgres managed databases. And we are working together with them. So they develop these specialists, which are agents that have already all the context that they need in order to use their platform effectively. So you can just add to your workspace and you can use them. Of course. We have the list of providers. So this thing is provider native agnostic. You can use any provider that you guys want, and you can use Hugging Face as a fallback, which means that this thing is capable, if your computer is good enough, to run models locally and do local inference with something that is called Candle. If you guys know PyCharm, it's the same thing, but on Rust. And last thing I wanted to show you guys is the use with No, but it's not going to load enough. Yeah, anyway. So that's all with my AI stuff. To finalize, I have something to show you. So we've talked about the federation and all of that, and I've talked many times that, oh, it is used for enterprise, yada, yada. But one question that people ask me many times is, okay, but how performant is this, right? Because, if some of the biggest enterprises are using it, and most of them complain about performance most of the time, I have to have a way to show this. So I built this. About 2 months ago, and let's hope it works. So this is one famous video of a video game that I like a lot, which is called Toho. And it has like a famous video that is like in black and white. And what I did is using AI, I picked that video up and I told it, okay, I want you to make every single frame of this video into a micro frontend. And I want you to load them at high speed so we don't notice whether it's a micro frontend seeing this or an actual video. So what you're going to see right now is a video of composing of 5,258 micro frontends being loaded. And this is how fast Federation can deploy this. So each one of these pixels that you see is one micro frontend being loaded at high speed. And to prove that, I can open this and I can show you the network tab going absolutely high wire. I don't know if you can see it properly. Maybe I can zoom a little bit here. No, it doesn't allow me to zoom. Come on. There you go. So you can see here all the requests going through and all of that. So yeah, this thing is performant enough for pretty much anything you can think of. Let's stop this. Can I go back to my slides, please? Oh, there you go. Okay, so to finalize, some takeaways. There you go. So out of all the things that I've talked through, some takeaways. The boundaries matter. So if you are thinking of maybe this will be useful and I'm going to give it a shot, please think about a little bit about what your trade-offs are. You're going to change complexity over your processes and your pipelines over to complexities about managing runtime code. So you have to have very in mind about your environments, about your deployment process, and also you have to understand that this is going to take time and you are going to find out things out of this. One of the things that people find the most is related to their dependencies graph, because there is 2 applications sharing code. And if your dependencies have conflicts between them, mostly related to minor versions or log file versions, you will notice them right away on bundle size. This will be available soon. I'm so sorry. I wanted to have it today. I couldn't. So that's how it is. Try Zephyr. If you have any application that you want to deploy, you can do it right now. So this little thing will just add the plugin over to your application. And the next time you build, it will be giving you a URL. It is totally free. So you can just give it a shot. Try Tap if you want. It is also open for everybody to try, and it is also has like a free tier. So just go to this link and download it. And if you guys want to try out some of the providers that are available here, and maybe not in the West, it will be much appreciated as well. So thank you.